Problem 1.81. In this problem, a layer of water flows down an inclined fixed surface with a velocity profile shown in the figure below. We need to determine the magnitude and the direction of the shear stress that the water exerts on the fixed surface for a velocity of 2 meters per second and a height of 0.1 meters. For us to solve this problem, we're going to assume that the fluid is a Newtonian fluid, and we're also going to assume that this is a steady state case. Okay? In this case, we cannot assume that the velocity is linear because they give us a profile for the velocity. Our goal is to be able to find the value and the magnitude of the shear stress. So we define the shear stress as the dynamic viscosity times the rate of shear strain. For that, we take the velocity and we define it as simply 2 YH minus y squared h squared, and all of this is multiplied by uppercase U. We take the derivative of this with respect to y, and we simply have the derivative of this, since it's linear, is simply 2 over h, and the derivative of this is simply 2y divided by h squared, and we keep multiplying by uppercase U. So we need to evaluate the amount of the shear stress at the surface. So that means that we evaluate tau at y equal to 0. So we evaluate this. So we're going to evaluate the u dy at y equal to 0. So notice that this term remains 2h. The second term is multiplied by y, which becomes 0. So this goes away. So it becomes this. So at y equal to 0, the amount of the shear stress is simply mu times 2u over h. And if we substitute all the information that it was given, and we find the value of the viscosity of water, looking at the table, we find that at temperature of 20 Celsius, we find that the viscosity is equal to 1.002 times 10 to the negative 3, and this is newtons times second divided by meter squared. We substitute all these values into the shear equation, and we find that the value of the shear is equal to 4.008 times 10 to the negative 2 newtons per meter squared. Now, in regards to the directions, since the flow is going down the hill, the shear stress will go in the opposite direction, meaning up the hill.